So in the slide previous to this one, I mentioned that, or previous to the slide that I talked about the distance formula in, I mentioned that this was the a use of the Pythagorean theorem. So, um, so what do I mean by that? So, what the distance formula tells you is basically how far you are between 2 points, right, on a coordinate plane. So if you've got your plane, okay, our first question was find the distance between the points -5, 0, -5, 0, and -2, 4. Find the distance between -5, 0, and -2, 4. So in order to do that, here we go. We've got 1, 2, 3, 4, 5, and I'll just change the color real quick. Here's -5, 0, and then 1, 2, and 1, 2, 3, 4, and here's -2, 4. And the question is, what is the distance between those 2 points? So the first thing I want you guys to understand immediately is that this is a diagonal line. Okay, if this were a line that were directly on top of the x or y axis, we could just count the number of, or even parallel to the x or y axis, we could just count the number of units it goes over. But this is a diagonal line, so we can't just count the units. However, what we can do is we can make this into a right triangle. We can count the units going left to right, and then we can count the units going up and down, and say that we have a right triangle here, and we can say basically that our little green line here is the hypotenuse. So the distance between these 2 points is the same as the length of the hypotenuse of a right triangle, right? So what we do is we need to figure out, this is -2 here, this is -5 here, right? Okay. This is 0 here, 0 here, and this is 4 here. So what we can do is we can say, how big is this leg here? Well, I count 1, 2, 3. That leg is 3. How big is this leg here? Okay, well, I count 4. From 0 to 4 is 4. Okay, and then we can see that if we just use the Pythagorean theorem, a squared plus b squared equals c squared, remember c is always your hypotenuse, okay, and so your legs are going to be, a and b is going to be right here. So I can substitute 3 for a, I can substitute 4 for b, and I can say that this is going to be 9 plus 16 equals c squared. 9 plus 16 is 25 equals c squared. And then I take the square root of both sides, and just the positive square root. You guys have learned by now that there's a positive and negative square root of anything, but just the positive square root of 25, because this is a distance, and distance is always positive, and I find that c equals 5. Okay? Now, if I were to use the distance formula in order to solve this, I would say that the distance equals the square root of, x sub 2 minus x sub 1 squared. Okay, so here's my x sub 2, here's my x sub 1, so -2 minus -5 squared plus y sub 2 minus y sub 1 squared. There's y sub 2, 4, minus y sub 1 squared. Okay, so what does that tell me? Well, look, c, if I go back to the Pythagorean theorem here, okay, since a squared plus b squared equals c squared, I can rewrite that as c squared equals a squared plus b squared, right? And then in order to solve for c, I take the square root of both sides. So the fact of the matter is that c is equal to the square root of a squared plus b squared. Well, as we've seen, a squared is -2 minus -5 squared, okay? And b squared is 4 minus 0. Okay, so so d equals the square root of, well, negative 2 minus negative 5 is 3, because negative 2 plus 5 is positive 3. So this is 3 squared plus, and then 4 minus 0 is 4. 4 squared. Take a look. Oh, I put a b there. That's weird. Just so you know, I'm doing this early in the morning. This is So look, c squared really is the square. C squared is 3 squared plus 4 squared, so c really is the square root of 3 squared plus 4 squared, right? Which is the square root of 9 plus 16. So d in this case, distance, is the square root of 25, which is 5, okay? So that's how you use, and by the way, that was the first example of using the distance formula. That's how the distance formula is related to the Pythagorean theorem. All right, so let's do at least one more of these. Example 2 says find the distance between the points negative 3 comma negative 2 and negative 4 comma 4. So this time I'm not going to draw the graph or anything like that. I'm just going to go ahead and use the distance formula. Okay, x2 minus x1 and negative 4 minus negative 3 squared plus y2 minus y1, 4 minus negative 2 squared. So distance, I forgot to put the equal sign. Distance equals negative 4 minus negative 3 is the same as negative 4 plus 3, which is negative 1 squared. Okay, plus 4 minus negative 2 is 4 plus 2, so plus 6 squared. So the distance is going to equal the square root of 1 plus 36, which is the square root of 37. 37 is, I believe, a prime number. It is, in fact, a prime number. So we just leave it like that. Distance equals the square root of 37. You could obviously find the square root on the calculator and approximate it with some kind of decimal, but in this case, we're just going to leave it as d equals the square root of 37. And that's how you use the distance formula.